Let's get started on the Advanced C course. So before I move on to my class in a detailed way, we should discuss about the lab setup. So there are a lot of users and everybody prefer to have a different environment, and a lot of people have asked me in the past which environment to use. Is Linux good or Windows good actually, right? What I have seen and what I have used is I've always used Linux environment because as you might know that Linux is being used as a backend for almost all largest websites in the world. For example, Google, Facebook, LinkedIn, Microsoft, even our own Sand Foundry, right? So Linux is really the operating system of choice in terms of programming, in terms of a very serious programming. Many of you, especially in India, are used to using Windows environment. If you have Windows, I think I'm okay with that. However, if you can somehow install a Linux partition or a Linux virtual machine on your existing Windows environment, then it will be really very good. There are a lot of variations of Linux if you're choosing Linux. So we have Ubuntu, we have Fedora, we have CentOS, Debian distribution, SUSE, a lot of old Unix operating environments. So you can choose the one which you can easily have access to. I prefer to use Ubuntu and Fedora sometimes. And the current lab that I'm going to work on, I will be using Ubuntu for my work. One of the good thing that can happen also is while I do a lot of lab demos, you will see a sequence of commands. They are very handy commands which are used in the companies, which are used in production environments by core developers. So you will also get a first-hand knowledge about some good set of Unix or nowadays Linux, so good set of Linux commands and how to use them. So in my lab, I'm going to use it pretty detailed. So that's another reason or another motivation for people who want to have a good hang on C programming should have a Linux based environment. The next question people have asked, shall we use some online compilers on C? Again, the short answer is no, but again it depends on the situation. There are lots and lots of online compilers. They allow you to write a piece of code and compile, and then you run the code, right? One of the objective of this C programming class is to understand how things work behind the scenes. So when you write a piece of C code, you will see the output and you will try to deduce, you will try to relate it to what's going on behind the scenes. A lot of online compilers will certainly give you an output. However, if you have a native machine, if you have a virtual machine Linux with you, then you can use a lot of additional commands on your command line, on your command prompt, to read more things behind the scenes. A lot of these things may not be possible with an online compiler. So really the short answer is no. Please have your own setup if you want to be an efficient C programmers who can do a really nice code when they join the industry. Okay, so let's get started in terms of theory. So I will do some amount of recap and I will stop at certain places where I think I have to emphasize more about the C language. So let's get started. So C is really a robust language whose rich set of operators and functions can be used to write any simple to complex program. Now, when you talk about programming language, there are so many programming languages, right? We have C, C++, Java, Python, and then nowadays very popular is scripting, JavaScripts. Uh, every language has their own role to play actually for different kind of programming situations. C language, when you think about, right, it is really core to the system. It's core. So when you think about system programming, then I think people have to think about C actually. Okay. What kind of operators it gives? I think you have studied in a basic level of C language that it has a unary operator, it has binary operator, ternary operator, and so on and so forth, right? The good thing is the language allows us to define our data types. So you have a common primitive data types as well as user defined data types. You can access a range of memory. You can access just a byte, or you can access a portion in a byte or a bit in a byte, right? So we have a lot of operators, we know we have operators to do bitwise operations, we have operators to do logical conditional operations, right? So the language has support for all kind of fundamental operations that you'd want to do on a piece of data or an object at a core level, at a system level, even at a hardware level. What I meant by this is really at a bit level. And C has a lot of functions, right? So you write your own functions, but C essentially is a collection of hundreds and hundreds of functions. The libc, the C library, right? C library is the common one, the one that you use primarily day in day out for your programming is printf and scanf and a lot of malloc, kellogg, those kind of operations. So it's a huge collection of libraries which does a lot of general purpose work, as well as specific libraries for specific environments, which allows us to write a really complex piece of code, not only the simple functions and simple code that we are used to writing, right? Now the beauty of C, right, and this is very important. Basically the compiler, the C compiler, it allows us to write both assembly level programming as well as the C programming code. So generally when you code in C, we have a C programming constructs, right? We have a if condition, while loop. So we are really using the C language. But if you know assembly language programming, right? So you can do assembly language for x86 processors or the ARM processor, right? So you can write your assembly code, and assembly code can be compiled by the compiler along with your C code, right? So you can have a project in which you can have assembly code for some real critical parts of your code. Assembly code are generally considered faster, right? So real critical parts of the code for a lot of interactions with the hardware, low-level interfaces, and you can have a lot of C programming code, right? So the project can have a mix of assembly, ALP, and C programming, and this allows you to really write a very good code at a system level. So almost all the system software that right, are written primarily in C language. Think about Linux kernel itself. Many people have an inkling, an inclination, an itch to write kernel code. But the kernel is coded in C, as we all know. It's a C and a lot of assembly, right? We have a lot of C. In reality, it is a GNU C. We call it GNU C, which is a kind of an enhanced version of C, actually. Okay, it adds a lot of capabilities to do a lot of interactions with the hardware much more efficiently. We have inline code, inline functions, right? We have obviously assembly, as I told you. So the compiler allows you, right, to do assembly level programming as well as C programming for your application development or a system software development, right? It's pretty versatile that way. And many people I have seen, they do a lot of coding for a lot of these embedded environments and devices, and they generally call it as an embedded C, right? So we C is getting embedded into the various handheld devices, various industrial components. So the language has a beauty in terms of coding at a very low level. And then the last one in continuation with that, programs written in C are efficient and fast, and that's the other reason that almost all embedded environments, they want a quick code, a very fast code, including our hardware, including our kernel, which is nothing but a layer on the hardware, right? So we pretty much write the code in C language. One of the other way to look at, for programmer is, when you say C is efficient and fast, what does it mean actually, right? Okay, so some examples might help. Think about, as a programmer, I'm sure a lot of people do malloc call, right? You do a memory allocation call, malloc. And if you say, I want to do a malloc of 50, then the compiler or the language will allow to give you 50 bytes only. It does not give you anything more than that, right? And if you use that 50 bytes of memory allocation and work on that memory area, you are pretty much okay. And then if you go beyond 50 byte, like 51st byte or the 52nd byte or something further, boom, you will have a crash of the program, right? Because the language will exactly do what you want to do as a programmer, and it does not really play around in the back end with respect to your memory and adding more memory as demanded. Some of the other programming languages that you might know, they allow you to just create a chunk of memory, and then the chunk of memory behind the scenes will keep on increasing further, right? Okay, and where the lot of load comes onto the programming language, other programming language, because they have to manage that memory, and then somehow they have to collect some garbages, all right, as the program runs basically. But C language is not like that. In C, the language will do as the programmer will want them to do exactly, and language will not do anything beyond that actually. Okay, and remember, you do a memory allocation using malloc, you are supposed to free it, because you allocated a memory, you have to free it. You allocated 50 bytes, you must allocate 50 bytes. You cannot, you must deallocate 50 bytes, sorry. You cannot deallocate out of 50 bytes, you can't say I want to deallocate 1 byte or 10 bytes, something like that. I cannot deallocate in chunks or pieces. No, not at all, right? So the language is pretty simple in terms of simplicity. It will do exactly what you want it to do. Okay, and it's just really fast. You have the capability to do operations in a much more better way, efficient way. Think of bitwise operations. You can always divide by 2 in just one bitwise operation, super fast, right? Pretty fast. Instead of do a div operation by 2, you can just say right shift, right? So language has the capability to to do a lot of things very fast, provided as programmer we know those things in a much better way, right? So let's look into the program compilation and execution process. Okay, so quickly, the source code of a program is written with a .c extension, and on compilation it produces an object code. So a lot of people get confused, what is an object code, right? Remember that object code is your machine level representation of the C program. Now machine level representation is very, very different depending on your runtime environment and depending on the processor that you use. So if you're working on Intel 32-bit hardware, or if you're working on Intel 64-bit hardware, or if you're working on an ARM processor, right? So there are different processor architectures. So you will have a different object code generated for them. They are like a machine level code actually, isn't it? Now this machine level code that is just a conversion of our .c file, right? So if you have .c file with a function called main, it's just a conversion of your main function into the corresponding machine level object code, right? Now, will we be able to run this object code in reality? No, we can't run the object code, because object code is just a compiled piece of code only for your functions that you have written. If you have written function main and F1 and F2, these 3 functions in your program, you just get the object code for that, the compiled code for that, but that is no way executable. You can't execute it live in the machine. For that, we require the support for your target platform. What is the target platform? Your Linux. So you're running a Linux 32-bit, Linux 64-bit, Windows environment, your Mac environment, right? Okay. So every platform has their own runtime environment. So this object file is basically linked by a linker. Okay. And the job of this linker is basically to link your program and then the dependencies on those programs, as well as your so-called loader, the runtime environments, right? So it links your runtime environment, it links your object code plus the dependencies, which are the library dependencies primarily, and finally generate a binary executable file, right? And that binary executable file is really the final stage of your compilation. And on Linux or Unix environments, historically it is always an a.out, and then if you're working on Windows and maybe other platforms, right, it may be .exe file. That's what we call it. Now this linker, right, linker can basically link your object file and generate an a.out, and you can have multiple methods known as static linking and dynamic linking. Okay, so in one of my classes, when I am talking about how things work behind the scenes, the entire process in detail, I will discuss in much detail with a demo about static and dynamic linking also. So on a Linux or Unix environments, the name of the file is a.out. So what we do, we simply type a.out and run our program. All right, so let's look into the first one. In terms of very good recap, any C program is a collection of functions that are supported by the C library. User-defined functions can be created and added to the C library if needed. So when you think about your C program, what do you really write inside your hello.c or in your a.c? You write a function, and then we write a function called main. Main is the entry point for your C programs. So you write a main function, and if main function is calling f1 or f2, then you have to also write those function definitions f1 and f2. If main is calling a printf or a malloc or a string copy, so many of you know that they are part of library, so they are library functions, right? So we have a lot of library functions basically. And if you are going to repeat a lot of tasks, if you're going to write a piece of code for your project which is going to be used by lots and lots of different files or programs, then you really want to write that particular piece of code as a function, as a user-defined function, and then you can add it to your C library. You can add it, you can create your own library, and then you can link your code or your project code with that library, because that particular function is going to be used extensively by different portions of your project, like hundreds of .c files. So a policy has to create frequently used user-defined functions into a new C library, right? So eventually what you see, a C program is a collection of functions, okay? And then we have our own functions, or we have a C library functions, or a new C library if really needed. Main is a special function, as you know, okay? So main is a special function, and it instructs the platform, your Unix or the Linux, right, platform, or the Windows platform, to say that yes, when you run your a.out or .exe, please jump into the main. Okay, so we are going into the main and then executing the function, the main function. As you also know that main has command line, we generally use the word command line arguments, right? So you type your a.out along with some hello world as an input, your command line argument that also gets passed to the main. So basically it's an interface between your shell, your environment or the platform, to your C program. So main is the real interface where the command line arguments are also passed into the main function, and classically we always say argc and argv, argument count and argument vector. And in some cases you have tools that you are writing, your C program is a new tool, then you also pass a third argument which is known as environment pointers, right? Okay, so these functions are generally starting and ending, we use the braces. So we have statements are enclosed between these two braces. Very important property of C programming, and I have seen a lot of programmers, lot of students fumble here. Any variable used in the program must be declared before using it. This is often an understatement, okay? I have seen many people code and they definitely declare that variable before using it, okay? But the idea is to declare the variable right at the beginning of the function, and not anywhere else generally, right? I've seen a lot of people, they try to declare a variable just before using it in their entire flow of the function, but that is never good practice. We must declare those programming variables at the beginning of the function or at the beginning of a block statement, right? If you have a nested block statement, you declare it because you potentially want to use it inside those block statements, else use them at the beginning of the function. And why do we want to do all of these at the beginning of the function? Because in the function, you might be using a lot of variables, and if you put them everything at the beginning of the function, then you will have a least amount of variables that you would define, because these are the variables which are going to be used inside that function. So you can optimize it very easily. Your code will look neat and clean. So it's always a good practice to declare, define right at the beginning of the function. Now some other tidbits. C programming variables are generally written in lowercase letters. I have used generally written, right, because people who have born and brought up with a Unix kind of environment, if you have studied programming from the Unix environment or Linux background, generally you see the classical books and the material, they all talk about lowercase letters. So we generally use lowercase letters for writing a C code. However, it's no offense to anybody else, right? So I have seen a lot of Windows developers and developers from other background, right? They try to use camel case notation. So I think it is just fine. Okay, so it depends on in which environment you have imbibed right from the beginning. If you're coming from the Unix or the Linux world, that's where I am from. So I pretty much use lowercase everywhere. And then statements are terminated by semicolon, right? Whenever you write a statement A equal to B plus C, yeah, you have to terminate and there's a semicolon, and we have to be careful about it, because for a lot of loops, if you have a wrong semicolon, the program just won't work the way you expected it to work. So we talked about lowercase letters, right? Okay. So where do we use uppercase letters in our C programming? Again, it's more like a guideline, right? So you use uppercase letters for your symbolic constants, right? So you'll have a lot of constants in your program which are symbolic in nature. Think about enumerators, right? So we use enumerations for efficient coding, meaningful coding, right? So you can use uppercase letters for your symbolic constants like enums, and anywhere else you think it is much more readable, right? Okay. So what are some of the additional details in a recap? So you have constants, you have variables, you have identifiers and keywords, right? As we all know, it's pretty simple. Constants, they do not change during the execution of the program. So you declare a variable as const, you know that it is going to be fixed forever. As opposed to variables, they always change during the execution of the program. That's the meaning of a variable, right? Okay. So always make judicious use of constant. It's needed only at few places, at important places. Okay, rest all are variables. Identifiers, right? So when you talk about C programming, right? So you have a C programming statement A equals to B plus C. Then the compiler will have to look into the token parsing, right, as part of parsing of the entire line. So it will say A equals B plus C. So there are A, B, and C. It has to really figure out what is A and what is B and what is C, right? Okay. And what is main? If you write a function called main and then an F1 and then an F2 and then you have a pointer, C programming pointer, PTR. You have an arrays, right? So arrays have a name. So remember, identifiers are the ones, which are used to define the names for these things, what I discussed, like variables, functions, your PTRs, and then arrays, so on and so forth, right? So they are basically names for your so-called data types or then objects or the code functions. Then what are keywords? Keywords, as we all know, they are well-known words. For in a for loop, do, while, int, char, float, if. I think you understood pretty well what I am saying. So when the C compiler does the parsing of the statements, right, it has to just break it down and try to see, yes, when I'm doing parsing, what are those? If A is greater than B, so it knows that it's an if thing, right? So if is a keyword. So and then A greater than B, A is a variable, it's an identifier, B is an identifier, right? So as part of token parsing, it has to really segregate all of these to make sure that the code is written with the proper syntax and then the compilation is successful. So keywords have well-defined, meanings that the compiler knows pretty much actually. Okay. All right. So what we should do next is we should move into the lab. So I've done a small theory. I will give a demo about the meaning of object file. So I'll also give a demo about semicolon. Okay, so let's jump into the lab exercise. Okay. So here I am. Look into this piece of code. Okay, so it's a very small code. The goal of this particular lab exercise is to understand the meaning of an object file. Okay, so when you look into this code, we are writing a simple hello sand foundry, a simple program. So the objective is different. The objective is not to understand what that program is. We all know what that program is and what will be the output. Okay. So we are going to do a compilation of this code. So watch out, when you do a compilation of this code, you are going to get a lot of data. So a.out file always gets created when you compile this code. Okay. Let me remove a.out once again and then say ls -l. You can see that a.out is no longer there, and I'm going to do the compilation now. Okay, so let's do the compilation and you get the a.out. What is the size of this a.out? It is 16 kilobytes, right? 16,704. So it is 16 kilobyte. And what was the size of our original program? What was our program? Our program was this. It's a very small program, right? It's a pretty small program. Do we think that the program is going to generate such a large object for this main function? The answer is really no. See, this is the final output of our binary last stage of compilation, right? So this is the final output. This is the binary, which is the final output of the last stage of compilation. So how do we go about creating only the object code? So we can always do a cc minus c. Remember, when you do a cc minus c, we are really looking into only our program, our .c object code. Okay, so let me do a cc minus c, and then I'm going to do a ls, right? When you look at, whenever you do a creation of an object code, this is the object code that we have created, and then you can see the size. It is hardly 10% of the size. Okay. So what you see now is some sort of a dichotomy, where you see that yes, I have this and then this. So what are the other data which is going into this particular output? And what is this, right? So this is really the machine level implementation or the compiler implementation or the object code associated with this particular function. That's pretty much it. And what is this? This contains your runtime environment related machine instructions. So a lot of functions are getting added to this to make sure that it runs into your runtime environment. Not only the runtime environment, we have references for printf, right? So printf is part of C library. It's a libc C library. Okay. So your C library code is also getting added here. Now this kind of linking is definitely a dynamic linking, okay, basically. So when you look into this file sf0006 object.o, it just says that it is basically a .o ELF 64-bit relocatable file. Remember, it's a relocatable file. It is not an executable file. No, it's not. It's not. Okay. Similarly, when you do a file on your a.out, what you see is it's a lot of data have been added here. Okay. So a.out basically it's an ELF 64-bit LSB shared object, dynamically linked. Okay. So when you run this code, so when you run this code, so remember it's a dynamically linked actually. Okay. So when you run this code, a.out, yes, it just works. Hello San Foundry. Can I run the object code? No, we just can't run it. As I told you, object code cannot be executed, right? Permission denied. Basically, it is not allowed it to run. There is no permission denied is something different. Some of you are from Linux or Unix background who can understand there's a permission on execute because a.out is executable. This is just an object. There is no permission to execute it at all. Okay. Even if I change the permission, for example, chmod +x, again I'm using Linux command, and that's what I said, never use an online compiler for serious learning. Okay, always have your own compiler, your own Linux environment. It will help you to learn many things about what I'm doing here, right, on the screen. So let me run this. I did a chmod. Sorry, it says I cannot execute there's a format error, right? So remember, you can't execute your .os, your object code. You require a support of runtime to generate your a.out. I hope you understood, the gist of what I am trying to convey here. The objective here is to understand what is a.out and what is your .o, right? So some of these commands are extensively used in your troubleshooting exercises. Okay, remember that file is a very important command. Okay, so this was in terms of object code. Let's look into some tidbits actually. Okay, so this is a tidbit. I repeat, it's not a great code. We just have to understand. So can you look into the code? Let's pause for just maybe 5 seconds. So this is a code, and when we try to run this code, we know that it's a for loop. So it's supposed to print hello San Foundry in a for loop up to 5 times, right? Okay, so let's compile this now. You get your a.out. So absolutely no need to worry. Okay, a.out. You compile it like this. You got 0, 1, 2, 3, 4, 5 times. So it's a simple code, as I told you. Let's understand the significance of semicolon, right? Okay. So some of you who have been coding C pretty much understand what it is. This exercise is just for the benefit of some serious coding, right? Sometimes. See, this is a for loop, and in this for loop we are trying to do a printf. So this works as expected. Sometimes I have seen a programmer puts a semicolon here. Okay. If you put a semicolon here without any change here, any idea what would be the output? So if you compile this code, and run it, so this is the code, right? What will be the output? Output will be only a single printf. So hello world 5. I think there's a stark difference here. Okay, so earlier we had earlier hello world 0, 1, 2, 3, 4, and this time when I'm running it, it is 5. Any idea why it is? I'm sure yes, we are all understanding it basically. Okay, so what has happened here is we started a for loop, and the for loop started with 0 up to a count of less than 5. It will try to do a plus plus. Why? Because we have a semicolon. And then once it increments it from 0 to 1, then 2, then 3, then 4, and then 5. So the value I becomes 5. Is 5 less than 5? Absolutely not. So the condition fails, and then you are out of this for loop. When you are out of this for loop, the value of I is 5, and then you display 5 here, right? Okay. Yeah, here the objective is, as I told you, just to explain you the importance and significance of semicolon, right? When you look into this, there are 2 statements here. One is this for statement, it's a loop statement, and this another statement, right? Now when you remove this semicolon like this, then we are really looking into a for loop in terms of for has to go into this printf every time on the iteration. Okay, so it's a continuation of your for condition, right? If you put the semicolon back, this is not the continuation for your for condition, because the for statement or the for loop statement is simply terminated with a semicolon here, right? So be aware of this fact, and just make a note of this. You have to be careful with your semicolons. I have seen a lot of programming time are wasted in debugging a code. Now this code is hardly 4 or 5 lines, but in an industry you have hundreds and thousands of lines of code, and if you put a semicolon wrongly because of some misunderstanding or not a proper understanding, right, then we'll end up hours and hours and sometimes days to debug the real problem. Okay. All right. So the purpose of these 2 exercises was to understand the meaning of an object code, what it means, as well as a tidbit about semicolon. Okay. In the next topic, I'm going to cover data types in C programming, and it is going to be very exhaustive topic because data types are the crux of C programming. Okay, so I will have a lot of focus on each and every data type. So see you in the next class. Thank you. Thanks for watching the video. We have put important links in the description and the comment section below. If you really enjoyed our video, please press the like button below. We plan to release one video per week. So go ahead and subscribe to Science Foundry by pressing the subscribe button below and turning on the notification bell.